See what are the categories of machine learning. We saw that machine learning is a subset of AI, basically help us to train to machines to learn from data or patterns. Okay, so essentially it's the subset of AI where systems or computers learn from data and improve their performance without being explicitly programmed. Uh, to be specific, instead of writing fixed rules, you can train a machine learning model, and we will do that as well, that can be able to learn from your data, input data, then using that is able to discover the patterns that will help you do what, do some particular predictions. Okay, think of it like teaching a kid how to, okay, think of it as the way you learn something. You can just read, absorb that information, simplify it, then use it somewhere else in a applicable manner. So once knowing that, today we will talk about something else. We want to see what is the categories of machine learning. What are the categories of machine learning? So machine learning has been divided. They have been divided into three categories. Machine learning algorithms has been divided into three categories. We have what's called supervised machine learning, and supervised learning, and reinforcement learning. Very interesting concepts. Very interesting concepts. Now, we will start with what are the some of the aspects. What does supervised learning, machine learning algorithms is based on? Using the algorithms there that we want to talk about, we're able to do what's called regression analysis. Regression analysis. Very common in statistics, those who are in statistics. Regression analysis is one of the first thing or the fundamental thing that you have to know how to do that. You'll talk about things to do with the R scores, p values, how you'll be able to interpret that in your data. The second one, we want to do what's called classification. Classification. In sometimes they call it segmentation. Okay, you can be given a bunch of data or a pool of data, then you will be able to do what, classify them based on gender, based on, okay, for example, purchasing habits. Some people maybe purchases groceries so much than that, maybe than accessories. So you can be able to, you will be able to classify your customers based on given demographic information. Maybe gender, you can go with that. Maybe sales habit, you can go with that on your data. Okay. The next thing we want to do what's called unsupervised machine learning. We want to see those algorithms that are helpful in what's called dimensionality reduction. Sometimes you can call it a PCA, or dimensionality reduction. The another one is going to do what's called clustering techniques. You will be able to read those algorithms that help you what's called clustering. By the way, all these particular things we learned in the first lesson, if you remember earlier on, we introduced them. The last thing is the reinforcement. Though we have another one in between, what's called semi-supervised machine learning that combines both supervised and unsupervised. But in most cases, it uses the supervised learning, that's labeled data. Okay, it uses so much. There's too much of labeled data in semi-supervised. So in most cases, you can classify it as supervised machine learning as well. So in between supervised and unsupervised, we have what's called semi-supervised, which uses both. What's that? What's called labeled data and unlabeled data. You will see that by context. The third one is what's called reinforcement learning. Reinforcement learning. How many people have been worried how things like okay, it's based on trial and error or rewards and penalty for that matter. What ideally it means, think of it how robot works. Okay, leave about the robot. That's now technical. I know. In your homes, you people have pets. You people have pets. For example, the best example is a dog. How do you train your dog now? If you say something like, if you whistle, it will come. If you click, it will go. Okay, those who are keeping birds, they are able to communicate with birds. How are they able to do that? There's some magic happening behind that. You are able to communicate with your birds. You are able to communicate with your pets. Okay. Now to take it to the next context, what's how robots operate. So you train machine learning based on what's called rewards and penalty. Acha nikwambia a simple story. Mbwa wako unasema siku moja ukumuita tu, if you call it if you say come, we can train a dog is such that ukisema English word like come, okay, ni kuja, it will come for to eat something, maybe it's time for lunch. But if you say go, not that it's a human being, it will go. And someone will be wondering, is this a devil or something? Is how is person able to communicate with his or her pet like dog? Because if you say come, the dog is coming to him. When you say go, the dog is going away. How? Now that's a good example to explain what's called reinforcement learning algorithm. So it's based on penalties and rewards. Maybe earlier on, this particular individual, every time he said come, he would throw a bone to his dog. Every time he say come, he will throw a bone to his dog. So after some time, the dog learns, okay, come means something, food. So every time say, okay, come, the dog will come to him. And then maybe the next time, let's say go, you become very wild. Don't take a stick, so the dog will go away. So every time the dogs, let's get something like come, it will approach the owner. Or when it hears go, it will go away or evade. Why? It has been trained on base called rewards and penalty, all trial and error, trial and error, trial and error until you get the exact result. That's how things like robots are being trained. Though now that's an aspect of computers or machines. You're able to train your computer based on that. A very nice thing I want to talk about, like what's called Markov decision processing or MDPs, where you have a rectangle or a square divided into segments, sections. So there we want to think of it like playing a chess. That's another example. A reward and penalty. Oh, if you move on the left and the opponent is up there, there's a fail. If you move on the left and the opponent is down there, there's a pass. Something of that sort. So there's those rewards and penalty. And for computers, you can think of it like having a grid box, a grid maybe containing a number of cells. So there you can define your failed, your rewards and penalties. So let's leave at that point. We want to talk about each and every one of them, plus the algorithms used there. I myself am interested in where I do research on machine learning, AI. I research on that. I'm very enthusiastic about that. It's my area of specialization. I am of interest on that. So let's dive into one of our machine learning algorithm. The first one is what's called supervised machine learning. Again, I'm just going to take you through over this, then we're going to do a practical example on each and every algorithms under these categories. Okay? We want to do what are the some of them supervised machine learning algorithms, why are they used, what are the mathematical intuition behind those particular algorithms, how does they work? Okay, how was ChatGPT created? How is a robot created? How is my Gmail able to notify, oh, this is a spam, this is a legit email? How can I create a model that's able to predict for me a price, maybe in a stock price? Maybe in the next 10 years, this stock will rise or go down. How am I going to do that? So that's what's called now machine learning in essence. So let's dive into what's called supervised machine learning by introduction. Let's get to understand what supervised machine learning is. After each, you're going to ask me any question in what's not clear. Just take a key note on that. Now, in machine learning algorithms or in machine learning, there's what's called labeled data and unlabeled data. Let's start from there. In machine learning, we have what's called labeled data and unlabeled data. So just as it sounds, unlabeled data, let me give you an example. I can have a bunch of images of cats. Then I'm just going to tag them cat, cat, cat. Whether it's a black one, whether it's a white one, whether it's a brown one, whether it's a mixed of that, whether it's having a blue eyes, whether it's having a black eyes. I'm going to label that as cat. Millions of data. Millions of data. After labeling that, I'm going to pass it to what's called a machine learning algorithm. Okay? Like what's called logistic regression or what's called random forest or what's called SVM. So we won't see those particular machine learning algorithms. So I'm going to pass this huge amount of data using a computer. Okay? Then my computer is going to learn patterns from this particular data. And say, okay, cat is having 2 years. Cat is having blue eyes. Cat is having fur, not human like hair, but fur. Oh, this is a cat. Once you do this, the chunk or I mean huge amounts of data, your algorithm, your computer will be able to learn that. So every time, just take a picture of a cat, throw it inside the model to tell you this is a cat. When you take something else like a dog to tell you no, this is not a cat. Maybe you define a rule to say that that's not a cat or that's a dog. You can train based on the number of pets you want. You can train for dogs, for cats, for chicken in one algorithm. So that's what's called labeled and unlabeled data. So for unlabeled data, you just give it random data, maybe cats, nothing not labeled, uh, thousands of dogs images not labeled, thousands of cows or calves images not labeled. So my machine learning algorithm will learn from, okay, there's what's called filtering. Just hold on. It will take the pixels, it will learn from the pixels of my data. You just say, okay, for cow, they're a little bit huge. They're huger than cats. So this is a cow. Okay. For dogs, they're not huge like a cow, but they're bigger than cats. So this is a dog. For cats, they're smaller. You can define rules to able to define or learn that kind of uh, what's called unlabeled data. So let's start with supervised machine learning algorithm. Based on what I've said, supervised machine learning algorithm learns from labeled data. Okay, supervised machine learning algorithms learn from labeled data. So they're trained on input and output pairs. For example, I have an input like if you see this particular image is labeled a cat. So the models basically learns to map inputs to correct output. To just give you maybe if I give you two images for a cat and a dog, and I'm going to label cat dog. So with your human being, you see okay because it's having 2 years, 2 small years, this is a cat. But for dog, oh because it's longer, this is a dog. So I'm able to label to learn from that. I'm able to map that input against the output. So my input can be like an image, then my output is what is the label? It's a dog or a cat. Yeah. So by doing that, you'll be able to predict or learn from new and seen data. New and seen data. Think of it this way: you're preparing for an examination. You're preparing for your examination. You don't know what's there in your examination. Okay? You don't know what's there in your examination. So how are you able to learn and then you can apply that and pass your exam? That's now a good example of what's called supervised machine learning algorithm. So you can go and take yourself through a bunch of tests, past papers, questions, all that. You expose yourself to all that. Then now you tackle a new question. Maybe it was on matrices or calculus. You do a bunch of calculus tests, calculus problems. So when you see a new problem of calculus, you're able to do that. Is that true, Mr. Dennis? Hello, Mr. Dennis, can you hear me? Okay, sorry for that.